Now let's look at this particular problem. Show that the relation R in the set A of points in a plane. So there is a set which has all the points, right? I can say set A which has all points, right? It has all points, say P, Q, R, S and so on. And the relation set is given as PQ, where distance of the point P from the origin is same as the distance of point Q from the origin. That means now say this is origin, right? This is origin. You have 2 points in the plane somewhere, P and Q. Now the distance between this and distance, so if I call this as origin, the distance from O to P and O to Q is same, right? That is OP is equal to OQ, right? OP is equal to OQ. Now, so how will I write the relation here? I will write it as P and Q, where P and Q are equidistant from where? From origin, right? From origin. So this is the relation. You have to prove that this relation is an equivalence relation. So basically here the relation will have multiple pairs. Since the points in the plane are infinite, relation also will have infinite pairs, right? So you could have, say for example, you could have R and S, P and S, right? You could have R, you could have S which is equidistant, right? That is all these distance from the origin is the same, right? And there could be certain points which are far away also in the plane, right? You could have so many points, but these points are not having the same distance as O and P, right? So now all these points are there in the set A, but in the relation set, you will only have those points which are of the same distance from origin, same distance. So those points are there. So there could be multiple other points, say A, B, C, D, E, F, infinite number of points in the plane. Now we'll have to prove that it is equivalence. To prove its equivalence, what you have to say? Equivalence means it should be reflexive, symmetric and transitive. For it to be equivalence relation, it should be reflexive, symmetric and transitive. Now let's first check reflexive. For reflexive, A comma A should belong to R for every point that belongs to A, right? We call this set as A, right? For every point in set A comma A should belong to R. So now in this example, they've given that P and Q are having the same distance from the origin. So you have 2 points, P and Q. So as per reflexive, both the points should be same. So P and P, right? Now this P and P, the distance of this point and this point from origin should be same, right? Now the point is the same, right? If I have the point here and if I have origin here, the distance is going to remain the same anytime, right? The distance is not going to change. It's not going to change. The distance is going to be fixed between this point and this point, right? Therefore I can say it's reflexive, right? So distance from O to P is going to be same. Therefore I can say it's reflexive, right? So this is reflexive. R is reflexive as P comma P belongs to R, or as P is having same distance from O. From O to P, you write it like this, right? This indicates that it's distance. Distance OP should be equal to OP. Distance from the origin for this point is OP. Distance from the origin from this point is also OP. Both of these are equal, right? Therefore, you say it's reflexive. So R is reflexive because P is having same distance from O, which is nothing but OP is equal to OP, right? Now we'll take symmetric case. For symmetric, it is straightforward, right? If X and Y belong to R, it should imply that Y and X should also belong to R. The reverse combination. So now I have P and Q which are equidistant, right? P and Q are equidistant from O, right? I will call the distance from P to O as OP and from Q to O as OQ. Let this be the distance. OP is equal to OQ. Now, so if OP is equal to OQ, OQ is also equal to OP, right? What is the relation between Q and P? Relation between Q and P is equidistant. This is the relation, right? It is equidistant from origin. Now, so if OP is equal to OQ, obviously OQ is equal to OP. Does it matter if I exchange these points, whether I put Q here, P here, or P here and Q here? Does the distance vary? No, right? OP is equal to OQ implies that OQ is equal to OP, right? So we say R is symmetric as OP is equal to OQ implies that OQ is equal to OP. Now we look at transitive case. For transitive case, if xy belongs to R and yz belongs to R, then first and fourth element, that is xz, should belong to R. Now, for this particular example, what we should do, we'll say distance OP. Let's take another point, say R. So we already have 2 points, P and Q. Both of these are equidistant from origin, right? That is, you have this origin, you have P here, you have Q here. The distance is same, right? Now let's take another point, say R. If I say that OP, distance between OP and OQ, it's already told in the question, OP and OQ is same, and if I say that distance between OQ and OR is also same, OQ and OR, OQ is equal to OR, right? Then can I say that OP is equal to OR, right? This is the first element, this is the fourth element. So basically if I take this as P, this is PQ combination, this is QR combination, then I should have PR, I should have PR, right? What is P here? OP. And what is R? What is the distance between O to R? OR. So if OP is equal to OQ, if OP is equal to OQ and OQ is equal to OR, can I say OP is equal to OR? I can, right? Because this indicates that OP is equal to OQ is equal to OR. All are equidistant. If this and this is equal and this is equal, that means all three are equal, right? So I can say, to satisfy transitive, I should say OP is equal to OR. OP is equal to OR. R is transitive as, you can say in two ways, PQ belongs to R and QR belongs to R implies that PR belongs to R, or I can write it as R is transitive as OP is equal to OQ, OQ is equal to OR implies that OP is equal to OR. Now, the relation is transitive, relation is symmetric, relation is reflexive. Now, since relation is reflexive, transitive and symmetric, so we can say it is an equivalence relation. Now, let's look at the second part of the question, which says that show that the set of all points related to a point P which is not equal to origin, right? Origin is 0, 0. Other than the origin, all the points related to point P indicates that circle is passing through point P with origin as center. Now, if you have points, say P, Q, R, S, P, Q, R, S, which are equidistant from origin, right? The distance is same, right? If you have set of points which are equidistant, it simply indicates that is circle, right? Only circle is one such geometric figure where all the points on the circle are equidistant from the center or from the origin. So we can say, since all the points have the same distance as OP, let's call the distance between OP as D. So if you have set of points where the distance from those points to origin is D, then we can say that the circle passes through point P with center as origin. With this, we've come to the end of this particular topic. We will solve some more problems in the next video. If you like this video, do press a like and share it. Thank you.